solving by substitution. This is a list. It says, solve one of the equations for x and y. If one of the equations is already in this form, you can skip this step. Substitute the expression found in step 1 into the other equation. This results in an equation of one variable. Solve the equation containing one variable and then back substitute to find the other, and then check your answers. So what it's saying is this. If I had this system of equations and I wanted to solve that system, substitution says solve one of the two equations for y. This is already solved for y. It says y equals 4x. You can substitute for the y in the other equation by saying, well, y is equal to 4x. So what you get is x plus y, which is 4x, equals 10. Now you have an equation in one variable. And it's because the y I made the substitution for is a shared y value. That's a y value the two of them have in common. Now, this says that 5x equals 10, x equals 2. So I know their shared x value is 2, and if y equals 4 times x, then y equals 4 times 2, which is 8. So according to the algebra, my answer is x equal 2, y equal 8, or it's going to be the coordinate point 2, 8. That says if I do a graphical solution, that's what I should see on my graph. Now I input those two into my calculator. I solved the first one for y. Y is equal to minus x plus 10, and then y is equal to 4x. And that's what I put in my calculator into y1 and y2. And then I'm going to do a zoom standard. This gives me minus 10, 10, minus 10, 10. There's the first graph. There's the second graph. And it should be in Mr. Rogers' neighborhood of 2, 8. And I can't necessarily tell. So I'm going to use what I call my free cursor. That's my left, right, up, down buttons. And I'm going to kind of make my way to the point of intersection. So I'm going to come across here. Okay, what is your problem? There we go. So I'm going to come across and then down. Now I'm not sure I'm on it, and in fact I probably am not. But if I look at the x and y values that are around that what appears to be the point of intersection, am I in the Mr. Rogers neighborhood of x equal 2? Is 1.96 about 2? Yeah. And is 8.04 about 8? Now that is a graphical cross-check that my algebra is correct. I came with 2.8. It looks about 2.8. It looks about 2.8. So it's like, okay, I think I'm right. And I can go back and check my answers, of course. It should be the case that x plus y equals 10. So is 2 plus 8 equal to 10? 10 equal 10. The answer is yes. And y should be equal to 4x. So is it true that 8, is that equal to 4 times 2? Well, 8 equals 8, and it checks. So algebraically it checks as well. Graphically it also checked. By the way, substitution is probably one of the least friendly methods of solving an equation. I don't like using substitution. But yet, in some instances, if you're going to take college algebra, you're going to run into the fact that you have no choice but to use substitution. It's the best way to work the problem. Now, here's one, and they're both in general form, so I've got to choose. Now, I'm going to have to solve for the variable, and the one I'm going to solve for is x, because he has the coefficient of 1. Nobody else has a coefficient of 1. So this is going to give me that x is equal to 3 minus 3y. And so I'm going to substitute in for that x right there, namely 3 minus 3y.
Wouldn't it be 3 plus 3y?
Oh yes, thank you. Why wouldn't I have been in trouble? So this says that 3 times x plus 5y equals negative 19. And we said that x is equal to 3 plus 3y. Now I have an equation only in y. 9 plus 9y plus 5y equals negative 19. 14y plus 9 equals negative 19. Subtract 9 from both sides. 14y equals, isn't that cute, negative 28. Divide both sides by 14 so that y is negative 2. Well, now I need to find x, and I know that x is 3 plus 3y, so that x is 3 plus 3 times negative 2, or x is 3 minus 6, or minus 3. So I got a negative negative. So this tells me that x equals negative 3, y equals negative 2, or the coordinate point negative 3, negative 2. Now on your test, I normally ask you to write just x equal, y equal. In fact, I put little blanks in there for you to be able to do that. Now, if I were to look now at the graph of this guy, and I'm going to turn the one we just did off and turn this guy on. I did a y equal. And graph it. So there's the first one. There's the second one. They're both negative. Woohoo! And now I come across and down. I'm going to look to try to get as close to that intersection as possible. And it's negative 3, negative 1.95. That's close to negative 3, negative 2. So it looks like I am correct. Cool. I often do that when I'm doing tests, by the way. Cross-check my answers when I do a key.